discussing one of the very important topic in network analysis or circuit theory, that is mesh analysis. Some textbooks they are mentioned loop analysis also. Loop analysis, mesh analysis, both are same one. So where we are applying mesh analysis? Mesh analysis applying in any closed loop. Okay. So we are applying KVL in each loop, writing the equations in terms of the loop currents only. In terms of loop currents. Whereas in the nodal analysis, currents KCL we are applying at each and every node. But here we are applying KVL in each loop and write the equations in terms of the loop currents only or mesh currents I1, I2, I3 and so on. Okay? And suppose any dependent sources are present, that controlling quantity or controlling variable try to convert in terms of the loop currents only. So here only variables are loop currents only, I1, I2, I3 and remaining currents. So if suppose any dependent source present, that controlling what either a voltage variable or a current variable, converting in terms of loop currents. Suppose any current source present between the loops. So directly it is not possible to apply KVL. We go for super mesh analysis. That we will discuss in the problems. First we will write the common equation. So two loop equations reduced into one loop equation. We will apply the super mesh equation. So first step, when you are applying mesh analysis, assuming that the circuit has n number of meshes, assign a clockwise mesh currents in each mesh. So my way of teaching is always I am assuming clockwise direction only. Currents I am assuming always, this is the best method. Always follow clockwise current direction. If 3 meshes are present, assume the currents I1, I2, I3. 4 meshes, I1, I2, I3, I4. Take the current direction, always clockwise direction. Second step, apply KVL in each mesh and write the equations in terms of the mesh currents only. Apply KVL. What is the KVL definition? Algebraic sum of the voltages in a closed loop equal to 0. So KVL we are applying in a closed loop only. Write the equations in terms of the loop currents only. Only loop currents are variables and some constant values. So equation voltage we are writing in terms of I into R drop. They will give the resistance value. I1, I2, I3 are the unknown values. So I1 into R1 or I1 minus I2 into R2, so on. So I into R, voltage we are writing in terms of IR drop only. That is, apply KVL in each mesh and write the equations in terms of the mesh currents only. Everything try to convert in terms of the currents only. Mesh currents, that is I1, I2, I3 and so on. Next one. For each dependent source present, write the controlling quantity in terms of I1, I2 and so on. Suppose any dependent sources are present in a network, that is current controlling variable or voltage controlling variable, try to convert in terms of I1, I2 and IN only. Okay, that we will discuss in the problems. Next one, if the circuit contains current sources, so create a super mesh by applying KVL. Suppose if the current source present between the two loops, it is not possible direct KVL equations. So first write the common equation, then that two loop equations write reduce into one loop equation only, that is super mesh equation. That we will discuss in the problems. How to apply super mesh equation when current source is present between the loops. We will discuss in the problem. Simply mesh analysis we can say KVL plus Ohm's law. KVL we are applying in a closed loop. Ohm's law means voltages we are writing I into R drop. Whereas the nodal analysis, KCL plus Ohm's law. Their currents are writing in terms of V by R, in terms of node voltages by R. But here, using KVL, voltages we are writing in terms of I into R drop. So, simply we can say mesh analysis equal KVL plus Ohm's law. So, okay, first step, assume the circuit has n number of, suppose 3 number of loops. Take the clockwise direction, assume the currents I1, I2, I3. Always better to use clockwise direction only. Okay. Next, apply KVL in each mesh and write the equations in terms of the loop currents only. KVL plus Ohm's law. for any dependent sources. Already here variables only I1, I2, I3. Any dependent sources, that current controlling variable or voltage controlling variable, try to convert in terms of loop currents only. And any current source present between the loops. So direct KVL it is not possible. We have to write the super mesh equation. First one is the common equation. Second one, super mesh equation, that two loops reduce into one loop equation. Okay. So how to apply mesh analysis in different circuits? We'll solve some exercise problems. Okay. Exercise problems. Yeah. Let us take the circuit diagram. Two voltage sources and some resistance combination. So in this one, how many loops are present? Okay. Already you know what is meant by loop. Loop or mesh is nothing but any closed loop. Where the current is flowing in a closed loop. If it is open circuit, current is not flowing. So here, three different types of loop, three different loops present in this circuit diagram. So assume the currents I1, I2, I3. Okay. So first loop currents I am assuming I1. Second loop currents I am assuming I2. Third loop current I am assuming I3. I1, I2, I3. Now, first I am applying KVL in a closed loop. So mesh analysis is nothing but a KVL plus Ohm's law. So KVL, what is the KVL definition? Algebraic sum of the voltages in your loop equal to 0. So I am applying KVL in this first loop. First I am applying KVL in loop 1. How to write loop 1 equation? This is the voltage source, current going from negative to positive terminal. So always take negative terminal only. If the current going positive to negative, then you write the positive, take the positive. Here first current entering negative, leaving from positive, so take minus 7. And what is the voltage across 1 mho? This is 7 volts is the voltage only, but positive or negative, because current going to negative to positive, we took this one minus 7. This 1 ohm is present between the first loop and second loop. So what is the current through the resistor? Voltage we are writing in terms of I into R. But what is the current through 1 ohm? Difference between these two currents. We are writing the loop equation in terms of, this is the loop 1 equation. So I1 minus I2 into 1. So this voltage across 1 ohm is I1 minus I2 into 1. This is the voltage across 1 ohm. Now current coming from clockwise direction, and next current coming from 6, observe the 6 volts. Current coming from positive, leaving from minus. So plus 6. Okay. Now, what is the voltage across 2 ohm? This 2 ohms is present between the first loop and third loop. So, difference between these two currents is current through the 2 ohms resistor. So, we have to write I into R drop. That is the voltage across 2 ohms. So, either I1 minus I3 or I3 minus I1. But we are writing the equation in loop 1. With respect to loop 1, I1 minus I3 is the current through 2 ohm. So I1 minus I3 into 2. That is plus I1 minus I3 into 2 equal to 0. That's all. So just simplify this one. That is 3I1. And what is I2 coefficient? Minus 1. And what is the I3 coefficient? Minus 2I3. And minus 7 plus 6. So minus 1 equal to plus 1. This is equation number 1. This is the equation number 1. This is minus I2. Minus 7. Okay. Just apply KVL. When the voltage source is present If the current going from negative to positive, take negative. If the current going to positive to negative, plus. So here minus 7 means because current going to negative to positive, so minus 7. Here current coming 6 volts, plus 2 minus, so plus 6. Remaining currents, this one is present between the first loop and second loop. So I1 minus I2 is the current through 1 ohm, I1 minus I2 into 1. Now this 2 ohms is present between the first loop and third loop. Therefore I1 minus I3 into 2. Just simplify that equation. Similarly, you try to write the equation number 2. Okay? Just try to write the equation, then check the solution. What is the loop 2 equation? Here, there is no voltage sources. Only 3 resistors are present in the loop 2 equation. 1 ohm, 3 ohm, 2 ohm. So, this 1 ohm is present between the second loop and first loop. 3 ohms is present between the second loop and third loop. 2 ohms is corner resistance. So, current through 2 ohms is I2 only. But, what is the voltage across 1 ohm? We are writing in terms of I into R. Now we are writing loop equation in terms of loop 2. In terms of loop 2 equation. How to write loop 2 equation? Loop 2 equation. This is the current through the 1 ohm is I2 minus I1. With respect to loop 1, I1 minus I2. With respect to loop 2, I2 minus I1 into 1. That is I2 minus I1 and into resistor 1. This is the voltage across. Now, this 2, current through the 2 ohms is I2 only. Therefore, voltage across 2 ohms is plus 2 into I2 plus. Now, this 3 ohms is present between the second loop and third loop. So, what is the current through 3 ohms? Either I2 minus I3 or I3 minus I2. We are writing the loop equation with respect to loop 2. Therefore, I2 minus I3 into 3. That is I2 minus I3 into 3 equal to 0. This is second loop equation. Just simplify this one. That is minus I1 and I2 coefficient, I think 6 I2. 1 plus 2, 3, yeah. 2 I2, 3 I2 plus 6 I2. 6 I2. Now what is I3 coefficient? Minus 3 I3. Minus 3 I3 equal to 0. This is second equation. First loop equation completed. Second loop equation completed. Now, third loop equation. This is the third loop equation. Here one voltage is present and 2 ohms between third loop and first loop. 3 ohms is present between the third loop and second loop. One is the corner resistance. So current through 1 ohm is I3. Same. Apply KVL in the third loop. Algebraic sum of the voltages in your loop equal to 0. Now, here current 2 ohms is present between third loop and first loop. Therefore, I3 minus I1 into 2 is the voltage across 2 ohms resistor with respect to loop 3. Now, this is the voltage source, current going from negative to positive. Okay, so minus 6. And this 3 ohms is present between the third loop and second loop. If you simplifying this one, I3 minus I2 is the current through 3 ohms. That is plus I3 minus I2, I3 minus I2 into 3. And now what is the voltage across 1 ohm? Current through 1 ohm is I3 only. That is I3 into 1. I3 into 1 equal to 0. This is the third loop equation. Just you simplify this one. What is I1 coefficient? Minus 2I1 and I2 coefficient minus 3I2 minus 3I2 and I3 coefficient plus 3 plus 2, 5 plus 6I3 plus 6I3 equal to 6. Now, Three equations, three unknowns. Just enter the coefficients in the any scientific calculator. You will get the answer. Okay. Already you know Kramer's rule how to solve this equation. Okay. So you will get the answer for these two problems. Yeah. I1 3 ampere. Answer, sir. I1 equal to 3 ampere. I2 equal to just a minute. I1 equal to 3 ampere. I2 equal to 2 ampere. And I3 equal to 3 ampere. 3, 2, 3 are the answers. Okay. Suppose you know the current values and you want to find out the voltage across some resistor. Suppose assume this is the voltage across V1. V1 is the voltage across 3 ohm. You know I1 value, I2 value, I3 value. This 3 ohms is present between the second loop and third loop. How to find? So I2 direction coming from clockwise, negative to positive, I3 coming from positive. So difference between these two currents into resistor, you will get V1. That is, from this equation, I3 minus I2 into 3, you will get, because I3 is the current going to positive, leaving from negative, whereas I2 entering into the negative. That's why I3 minus I2 to 3. Like this, we are applying mesh analysis. Okay, just simply we can apply KVL plus Ohms. Algebraic sum of the voltages in your loop equal to 0. Apply that one and write the equations. Everything in terms of the currents only. Everything in terms of currents only. This is first problem. Next, second problem. Yeah, second problem. So yeah, here one current source is present between the loops. So directly KVL, it is not possible. Directly KVL, it is not possible. So we go for super mesh analysis. So first our step is identify the total number of loops. How many loops are present in this circuit diagram? That is 3 number of loops. Assume the current direction always clockwise. This is I1. This is I2. Next one I1, I2 and I3. Okay. So this current source is present between the first loop and third loop. So here directly KVL it is not possible. If you apply KVL, this is the voltage. Current through 1 ohm we are writing I into R. But how to write the voltage across the current source? It is not possible. This is also current only. So what is KVL definition? Algebraic sum of the voltages in your loop equal to 0. Okay. Now, first directly you apply normal KVL in loop 2 equation. KVL in loop 2. This is normal KVL equation. What is the KVL equation? Algebraic sum of the voltages in your loop equal to 0. Now, this 1 ohm is present between the second and 1. That is I2 minus I1 into 1. This is the voltage across 1. This is present between the second and loop. We are writing loop equation with respect to loop 2. That's why I2 minus I1 into 1. Now, this 2, current through the 2 ohms is I2 only. Therefore, 2I2 plus 2I2. Next, this 3 ohms is present between the second loop and third loop. That is 3 into I2 minus I3 equal to 0. Okay. Simply KVL plus ohms. So, algebraic sum of the voltage in your loop equal to 0. Voltage we are writing in terms of I into R. Now, after simplifying this one, what is I1 coefficient? Minus I1 and plus 6I2 and minus 3I3. Minus 3I3. From this equation, this is assume first equation. Okay. Now, how to write the super mesh equation? First, you write the common equation. This current source is present between the two loops. So, difference between these two currents equal to 7 ampere. Whether either it is I1 minus I3 or I3 minus I1, how to identify? I1 current, check the current direction. I1 direction and this current source direction is same. Whereas I3 current source direction, opposite to the current source. So I1 current source direction is same as the 7 ampere. Therefore, I1 minus I3 equal to 7 ampere. That is the second equation, common equation. That is I1 minus I3 equal to 7 ampere. This is the second equation. Not I3 minus I1 because I3 direction, current source direction opposite. So I1 direction, current source direction same, clockwise same. I3 opposite. That's why I1 minus I3 equal to 7. This is the second equation. 3 loops means definitely you have 3 equations only. First is the normal KVL, loop 2. It is not related to current source. And one is the common term. Next, how to write the super mesh equation between the first loop and third loop. Except this common term. This common term is over. Except this common term, remaining all voltages with respect to loop 1 and 2. Okay, with respect to loop 1 and loop 2. What are the remaining voltages? 7. 7 positive or negative? Current going, I1 is going negative to positive. That is minus 7. Now, this 1 ohm is present between the first loop and second loop. So, I1 minus I2 into 1. This is the voltage across 1. What are the remaining 2 voltages? Voltage across 1 ohm, voltage across 3 ohm. These 3 ohms is present between the third loop and second loop. So, difference between these two currents, I3 minus I2 into 3. I3 minus I2 into 3. I3 minus I2 into 3 is the voltage across 3 ohm. This current through the 1 ohm is I3 only. Therefore, I3 into 1. I3 into 1 equal to 0. Just you simplify this one. You will get answer minus I1 plus I1 minus 4I2 plus 4I3 equal to 7. This is equation number. This is super mesh equation. So, okay. Once again, observe this one, super mesh equation. How to write super mesh equation? Current source present between the first loop and third loop. So, first common term, the difference between these two currents is this current source value. So, I1 minus I3 or I3 minus I1. I1 direction, current source direction is same, but I3 direction, current source direction opposite. That's why I1 minus I3 equal to 7 ampere. So, this common term is over. Next one. How to write the super mesh equation? So, first loop, third loop equation combinedly writing as one equation, that is called super mesh equation. What are the remaining voltages? 7, 1, 3, 1. So, current this is 7, current going negative to positive, minus 7. And what is the voltage across 1 ohm? Difference between these two currents, I1 minus I2 into 1. Now, these two are completed. Remaining 2 voltages, voltage across 1, voltage across 3. Combined equation. This 3 ohms is present between the third and 2. Therefore, I3 minus I2 into 3 plus I3 into 1 equal to 0. Simplify that equation, we will get this equation. Now, 3 equations, 3 unknowns. Just by applying Cramer's rule, enter the values in the calculator, you will get the answer. Answers are, that is I1 9 ampere. Answers are, I1 you will get 9 ampere. And next one, I2 2.5 ampere. 2.5 ampere. I3 2 ampere. I3 2 ampere. Just you concentrating how to write the equations. If you know how to write the equations, remaining calculation just enter the values in any scientific calculator. Okay, equations that button is there. That is 2 unknowns or 3 unknowns. Press that value. enter the coefficient, directly you will get x, y, z values or I1, I2, I3 values. Okay, this is the process. This is the, here we are applying super node. When the current source present between the two nodes, we are applying super node equation. Next, last problem. Continue. Now, next problem. One dependent source is present and that is a voltage controlled current source. So here we are converting controlling variable in terms of the loop currents. At the same time, this current source is present between the loops. We go for super mesh equation. How to write the equation? So apply our procedure. How many loops are present? 3 number of loops are present. This is first one, I1. This is second loop, I2. This is third loop. Okay. Always assume clockwise direction. Always assume clockwise direction. Now, here, how to write the loop equation? Okay. Now, first try to convert this Vx controlling variable in terms of the loop currents. Vx is present voltage across 3 ohm. This 3 ohms is present between the second loop and third loop. I3 direction first entering into the positive, leaving from negative, whereas I2 direction entering negative, leaving from positive. Therefore, difference between these two currents is current to 3 ohms. So, how to write Vx value? Vx equal to difference between these two currents, because I3 minus I2 into 3. Vx is the voltage across 3 ohm. Voltage across 3 ohm is difference between these two currents is the current to 3 ohms. Either I2 minus I3 or I3 minus I2. Why we took I3 minus I2? Because current entering positive. I2 direction into negative. Therefore, I3 minus I2 into 3 is the voltage across 3 ohms. So, one step is over. Now, first equation. This is the corner current source. So, no need to apply KVL. Already given I1 value in the circuit diagram only. I1 current direction, 15 ampere current source direction, both are same only. Corner current source. This is the corner current source. So, I1 value current source direction is same. Therefore, I1 equal to 15 ampere. One equation. Already you know one variable. So, just we have to find I2 and I3 values. Just we have to find I2 and I3 values. Now, how to apply this one? We go for super mesh equation or first write the common equation otherwise. This current source, this is current controlled, voltage controlled current source. Now, when the current source present between the two loops, first write down the common equation. Either it is I1 minus I3 or I3 minus I1. I1 direction opposite to this current source, this is upward direction. I3 direction and this current source direction is same. So, how to write? I3 minus, just a minute. I3 minus I1 equal to 1 by 9 Vx. 1 by 9 Vx. Because I3 direction current source is same. I1 opposite to this current source, though, therefore I3 minus I1 equal to 1 by 9 Vx. What is Vx? Everything we have to write in terms of the loop currents only. So Vx already we converted in terms of loop current. This Vx is depending upon voltage across 3. So I3 minus I2 into 3. Substitute that value. That is I3 minus I1 equal to 1 by 9 multiplied by 3 into I3 minus. After simplifying this one, you will get the equation and substitute I1 also 15 ampere in this equation. Substitute I1 equal to 15 ampere. You will get I2 plus 2I3. I2 plus 2I3. Okay, just check this equation. Yeah, this is second equation. Now second loop equation, normal KVL only. How to write normal KVL equation? Loop 2 KVL equation. Loop 2 KVL equation. Algebraic sum of the voltages in a loop equal to 0. This 1 ohm is present between the second and 1. Therefore, I2 minus I1 into 1 is the voltage across 1 ohm. And this 2 ohms, current through 2 is 2 only. 2 into I2. This 3 ohms is present between the second and third, plus 3 into I2 minus I3 equal to 0. Just you simplify this one. You will get that equation and substitute I1 value 15 ampere. So you get the equation in terms of I2 and I3 only. That is 6I2 minus 3I3 equal to 15. This is third equation. Solve these equations, you will get the answers. Already you know I1 value 15 ampere. Already given in the problem. I1 value 15 ampere. I2 equal to that value 11 ampere. I3 value 17 ampere. Suppose I want to find out the Vx value. Vx value. How to write? In this problem actually we have to find Vx value. How to find Vx value? Vx already we converted in terms of the loop currents only. That is Vx equal to I3 minus I2 into. So approximately we get that value 18 volts. Okay. These are the three different problems. First one we discussed that one. Without any dependent sources, without any controls, current source. Just apply KVL, write everything in terms of the loop currents. First one. Second one, when the current source is present between the loops, we go for super mesh equation. One is the common term, either I1 minus I3 or I3 minus 7, common term. Second, these two loop equations writing common equation, that is the super mesh equation. Second loop, just normal KVL only. Solve the equations. Third loop equation. Here also current source. This is dependent current source. First convert this controlling variable in terms of the loop currents and write down the equations. Common term and normal KVL in the loop. You will get the answers.